Gamma radiation is the strongest form of electromagnetic radiation. It has the most energy because it has the shortest wavelength.
The emission of gamma rays does not alter the number of protons or neutrons in the nucleus, but instead has the effect of moving the nucleus from a higher to a lower energy state.
Unstable to stable.
Let's take a look at our problem.
A negative beta particle and a gamma ray are emitted during the radioactive decay of a nucleus of lead-214.
To write the equation for this reaction, we need to find the components the lead is going to be broken down into. We're told in the problem that a gamma ray and a beta particle are going to be emitted. Now we just need to know the third element. We found the element to be bismuth because if a beta particle is being released, that has an atomic number of -1, and the atomic numbers have to add up. So a -1 plus 83 equals 82, and 83 is the atomic number for bismuth, so we found bismuth to be the resulting nucleus.
So, gamma radiation is so much more harmful than alpha or beta radiation because it has the shortest wavelength out of all the waves on the electromagnetic spectrum. And if we look at our equation, E equals Planck's constant times the speed of light over wavelength, we see that energy and wavelength are inversely related. So the smaller the wavelength, the larger the energy. And the more energy, the more harmful the wave can be.
To determine the energy released during this reaction, we must find the mass lost over this reaction. To do that, we'll take the mass of lead-214, subtract the mass of the created nucleus of bismuth, and then subtract the mass of a beta particle. And this will give us the mass lost in the reaction. We took that mass and converted it from AMU to kilograms and got 1.735 times 10 to the -29 kilograms. We took that and plugged it into our E equals mc squared equation and got 1.56 times 10 to the -12 joules.
Joules?
Joules?
Joules.
Joules?
Joules. Julia!
The end!